Now I decided to make one more video lesson about the induction. So here we will solve problem with the sequences. So I hope you did understand the idea and you will understand after this one. Okay, so what's given? Sequence is defined. The first term is 2 and un plus 1 is given this form. If you have these conditions, then it's this one. So what's your proposition is? What's your statement is? Your statement is that you have the first term and un plus 1 equals to un divided by 2n plus 1 in brackets for all integers. Okay, I can write it shortly. And then you will have this formula, 2 to the power 2 minus n divided by n factorials. Okay, so what do we need to do? First step is a basic step. We need to check for the, as it's a positive integers, we need to start with the P1. And for P1, the left-hand side, okay, this statement is U1 equals to 2. So, which is, okay, given already. And let's check when n equals to 1, whether this part will be 2 or not. So, we'll have U1 equals to the power 2 minus 1 divided by 1 factorial, so it will be 2. As you can see, left hand side and right hand side is equal, then P1 is true. Then we assume that the kth step is true, which means that uk equals to this statement, to the power 2 minus k divided by k factorial. So this one I imagine, we assume that it's, we do not imagine, we make assumption it's true. Then from here we check the k plus 1 step. The k plus 1 step will be, from here I need to go from the givens, uk plus 1 must be equal to uk divided by 2k plus 1. Now from here my aim is, let me just note that you do not have to write in the papers in exam. I just want to give you an idea what your aim is. Your aim is to go, if you imagine that it's a uk plus 1, whether you find this result, to the power 2 minus k minus 1 divided by k plus 1 factorial. So if you can find this result when simplifying this part, then your statement is true, correct. So let's go. So what's the uk from our assumption? We need to use it. It's here. It's given. So it will be to the power 2 minus k divided by k factorials divided by 2 plus k plus 1. Right? So if you just write it in simple form, if you divide them, it will be rewritten like this: k factorials times 2k plus 1. And here I can take 2 up because e to the power 1, so it will be to the power 2 minus k minus 1 divided by k factorials times k plus 1. And from here the numerator is 2 1 minus k divided by, and this part denominator you can write as k plus 1 factorials, if you remember from factorials. And now we are done. As you can see, I came to my aim. I was looking for this part so I could show it. Why it's always good to write it? Because sometimes it's not easy to see the simplified form when you write it, so you know where to go. If you go it correctly, then it means that you found correct statements. So from here you say that when P1 is true, again at the end you need to say true, and pk plus 1 is true whenever pk is true. Then your statement pn your statement, we know what statement is. Then pn is correct. Okay, this statement all, okay, let's write shortly, is true for all and positive integers.